In this example, we're trying to solve the following equation. Notice that we are in radians since we're using the variable x, and we're looking for all of the angles between 0 and 2 pi, where this side of the equation would equal the square root of 3. It's always a good idea to look at the graph before you try to find your answers. That way you know how many you need. And so here we have the graph of the left side of the equation, and then here is the line square root of 3. And so I can see in between 0 and 2 pi that I'm going to find two different answers. All I'll need to find is one of them, and I'll be able to find another by adding or subtracting multiples of the period. So right away to start, there isn't a way that I can get x alone as this is right now. And so if you think back to the sum and difference identities that we were looking at in class, this resembles one of them involving tangent. So I have a tangent of an angle minus tangent of another, 1 plus tangent of the first times tangent of the second. So looking at those identities for tangent, we can see that it follows the same pattern right here. Tangent of an angle minus tangent of the second divided by 1 plus tangent of the first, tangent of the second. That tells me that I can rewrite this as a single tangent of a difference of those two angles. And so I can rewrite my equation as the tangent of 2x minus x and set that equal to the square root of 3 instead. This makes this problem a million times simpler because now I can rewrite this as the tangent of x equal to the square root of 3, and now I can find angles where regular tangent equals the square root of 3. Keep in mind that tangent is positive in the first and in the third quadrant. This is a ratio you could find on your unit circle. If you didn't think to do that, you could do the tangent inverse in radian mode of the square root of 3. And you will get 1.047. That's an approximate angle. If you did look to your unit circle, you would end up finding the angle pi over 3. So that is one of my solutions. To find this other solution, we can see that they're 180 apart. So in radians would be pi apart. And so my other angle would end up being 4 pi over 3. And again, you could verify that this is right with your calculator. You could take pi divided by 3. This is the same exact angle that it gives us. This one is just in terms of pi. Keep in mind when we were looking at the graph, we only needed two answers. And so now we have them both by adding pi to the first one, and so we are done.